Welcome everyone to the Tricks of the Trade of, on a decade plus of Active Directory. I am Jairo Cadena. I am a program manager in the Active Directory team, and I have been with Microsoft over 9 years now. I joined the Active Directory team back in 2005 as a developer in test, where I could own the depths of different components. And then after a while, I moved to the PM organization, where I could and I have been able to design some of these new versions of the Active Directory components. I want to mention that this is a 400-level session, so this means that this is for you, experts in Active Directory, that know very well the fundamentals of the product, that have deployed and configure and operate Active Directory on a regular basis, that understand how the different components interact among them. And I'm mentioning this because we are not going to be able to dig into the context and background of the topics that we are going to cover in the session. However, I will say that there's some 300-level content that will help introduce some of these topics. So I guess there will be something for a variety of different levels. If you have deployed and configured Active Directory, I'm confident that this will be valuable for you. So while I was preparing the different takeaways for the session, the one objective that I want you to take away from here is that you are going to be able to be more effective in Active Directory. And that could mean different things, depending on your own experiences with AD. However, I want to mention these specific 5 points. One is that you are going to be able to get to the root cause of the different problems in a more effective way. That you know what tools to use and when to use them. That you can deploy more optimal Active Directory topologies. That you understand the different considerations that deploying Win2K3 with RODCs, for example, you need to have in mind. Or what about the different sites? Where do you place different domain controllers? How you can be more effective when upgrading from down-level versions of Active Directory to new versions of it. That you can decode those otherwise illegible to the human eye while you are diagnosing or troubleshooting that specific issue. And that you, in the end, can see Active Directory in a more integral way. That you can understand what are those different components that a distributed system such as AD comprises, and what are those specific points in which those components interact with. And I'm positive that you will be able to find many other takeaways based on your different experiences with AD. Now, you would imagine that in 10 plus years, we would have picked up some good content around AD. And I'm going to talk to you about my experience as a developer in test. I'm going to talk to you about my experience as a program manager while designing some of the new features. What I'm saying new is, the recent features in Win2K8 R2. And it would be impossible to cover in the next 75 minutes all that I would love to share with you. However, I have selected a specific set of topics that I find that are the components that probably are less understood from my experience in the last 5 years with AD, 5-6 years. But I want to let you know that I have prepared also an appendix of around 200 slides that you will be able to refer back after the presentation, and you will find very interesting topics, well beyond what we have today. And additionally, you will find context that will support what we are going to talk in the next 75 minutes. So I highly advise and I encourage you to go back and see the appendix and see the whole deck. You will find a lot of gems of knowledge on Active Directory. Some of the topics you can see in the slide, but you will find a lot more in the deck. Now, without further ado, let me go directly into the meat of the presentation. The first component that I have selected is a component that I personally own. and that I love very much. It's a component that I owned when I joined AD as a developer in test, and I quickly realized how important that was. I also realized that it was a component that it is not very well understood, and understanding the behavior of this component, which is DC locator, I am positive that you will be able to get to those root causes a lot faster. So why is this important? Well, DC locator is a component that is used virtually everywhere. From the tools that you use to troubleshoot, to diagnose, or to manage the directory, to the critical processes that Active Directory have underneath. So think about domain join process. Think about time synchronization issues. Think about secure channel issues. Some of those typical problems that you have seen most likely would have a cause in DC locator. Every access to the directory requires a domain controller, and DC locator is the key component that will provide that requester that domain controller. Now, also, one thing that I've noticed is that DC locator can be understood as the mechanism to locate DCs, and certainly is that. However, it is way more than that. And the reason why I'm mentioning this is because, well, if you know that DC locator supports all the site coverage, for example, functionality underneath, or the actual DNS service records registration, then you will be able to see this component in the right way. As you know, as most of you maybe know, it resides in netlogon, runs in LCSS process. And in terms of communication requirements, it uses UDP 389, which is what we call the LDAP ping. And I will talk more about this in the next slides. And of course, relies heavily in DNS. Now, if you want to have a hands-on experience on what DC locator actually does, you can just use nltest.exe. So actually, I would like to assess the audience at this point. By show of hands, how many of you are familiar with nltest? This is great. Almost, I see hands everywhere. Now, nltest does more than just DC locator. However, you will find functionality exposed in nltest for DC locator. Some of the specific functions are dsgetDC, they're very well known. But also we have dsget site coverage to know what specific sites that particular DC is covering. Or DS address to site names that when we introduced back in 2008 when IPv6 was also introduced in Windows. And registration functions, how to be able to deregister records in DNS. Also that was something that we introduced back in 2008. Now DC locator is fundamentally a client-server component. And it will have multiple settings that you will be able to tweak, both on the client and server side. And you will be able to tweak those both by policy or by registry. So anytime that I will refer to specific settings in this session, please remember that you will be able to do both in group policy and registry. Now, as I told you before, it is critical for you to understand how DC locator works. Now, let me, another question. By show of hands, how many of you are familiar with ADAC, or Active Directory Administrative Center? Okay, we have probably half of the room. Now, ADAC is a tool, it's a management tool that we introduced in Win2K8R2. And it relies on a protocol that we also introduced back in 2K8R2 that is called ADWS, Active Directory Web Services. Think about ADUC is to LDAP, to TCP and UDP 389, as ADAC is to this ADWS new protocol, which is 9389, TCP 9389. So when you are opening ADAC for the first time, then the first thing that ADAC will do is request a domain controller that supports this new capability, which is ADWS. So what will happen is that ADAC will request to DC locator in that machine a DC that supports a DWS flag. Now, DC locator will go to DNS and will say, hey, DNS, please give me the list of DCs that you have registered in this particular site. So DNS will return to DC locator, well, these are the DCs that I have in my white pages. But given that DNS doesn't have all the information about the capabilities that a domain controller supports, then DC locator will start pinging one by one. And the way we have designed domain controllers is that when a domain controller is pinged, and we'll talk more about this is an LDAP ping, a domain controller will return a specific information about the domain controller, the domain, and the client name. So in this case, if the domain controller does not support ADWS, then DC locator will just go to the next one until it finds a suitable one. When it finds one, then that DC is returned to the client. And then in this particular case, ADAC will take that domain controller and will start doing the rest of the functionality. One thing that I want to mention is that the information returned by the domain controller includes the client site name. So this is important because with the introduction of IPv6, clients can have multiple IP addresses. So the IP address that is used to perform the LDAP ping is then taken by the domain controller, calculated where the subnet is mapped to, and then will return that site to the client. If the client receives a site name that differs from the site name the client believes it is, then all the process will start again, and the client will go to DNS and will tell DNS, please give me now domain controllers, but in this specific site. When I say the client site that the client believes it is basically the site that is cached in it. So let's talk about this LDAP ping. What is that about? Well, DNS doesn't know all the story about that, about the different capabilities that domain controllers can provide. So it is the responsibility of DC locator narrowing that list that DNS returns to the client and guarantee a specific domain controller that meets some criteria given by the requester. It's a connectionless and a non-authenticated ping through UDP 389. And one interesting point that you need to have in mind is that DC locator will ping up to 55 domain controllers. Now, you will ask me, why 55? Why not multiple of 2, or probably multiple of 16? That is more typical to see these limits. So I will say, I won't answer you this question now, but I will use this as a hook so you can go to the appendix and see why is that. And I can tell you, it is not because it was a lucky number of the developer trying to code this functionality, but it has a specific meaning. So I encourage you to go to the appendix. What I will tell you is that this can have some considerations. So again, by show of hands, how many of you believe that this is a cause of a concern? We have one in the back. Thank you, gentlemen. My question is, the limit of 55 domain controllers, is that a cause of a concern? Is it something that we need to be aware of? We have one hand here, another hand there. That's great. Well, I can tell you that the answer is, it depends. And as every other Microsoft answer. Now, the reason why you might or might not need to be aware of this is that if you are in a domain that contains more than 55 DCs, and there are very few domain controllers that meet a specific capability, you run into the risk of not being able to find a suitable domain controller. So let me picture it this way. You are super excited because you have finished rolling out Windows 7 in the client machines and Win2K8R2 in the server machines. And you have deployed your first Win2K8R2 DC. So now you go to your admin machine, you launch ADAC to play with the new capabilities. And the first thing that you will see is that it times out. And then you see something as in the error message saying that there are no suitable domain controllers. And then you freak out because you are in control of all the domain controllers. And you then check all the DCs and they are up and running. And then you're asking why I'm getting this. So then you try again, and this time ADAC works fine. So what happens is that DNS will return the service records, and based on the priority and weight of these service records, DC Locator will randomly create a sorted list of domain controllers. And it can happen that given that you only have one Win2K8R2 in your domain of 70 DCs, sometimes the Win2K8R2 DC will fall into the 55 first or not. So that's where you need to be aware of that consideration. The question is there a registry entry that you can bump it up? The answer is no. But of course, there is hope if you lead into this situation. Things that you can do to avoid the risk of getting into this situation. Well, the recommended way would be to start rolling out more Win2K8R2 DCs. However, you can play with the weight, for example, in the service record, or less recommended way, you can play with the priority as well. Now, let me move on and talk about what capabilities can and what capabilities cannot be discovered by DC Locator. So certainly all the DNS information that is registered as service records is located by DC Locator, which includes the primary domain controller, if the DC is a GC, what site the domain controller is in, and if the DC is a KDC or not. The rest of the different capabilities will be given by the LDAP ping. So that includes, is the DC a time server, for example? Is the DC an ADWS? And there are some more. Now, not all capabilities are discoverable through DC Locator, and that includes Fissimo roles. So you cannot tell DC Locator, hey, please give me my read master. Or you cannot tell DC Locator, hey, give me a specific DC that has this optional feature enabled or not. So you need to be aware of that as well. Now, probably for those of you who have used NLTest, this is a pretty familiar output. But what I want to highlight here is that one of the attributes that the DC returns to the client is the client information, and that is marked as our site name, and that's the value that will be cached in memory by the client. So next time the client is requesting a domain controller, it will use that site to tell DNS, please give me only the DCs in that specific site. In our case of ADAC, the ADWS flag is shown as WS in the output of NLTest. And this is the output, the very well-known output. If you see this, you can automatically understand that there's a problem locating domain controllers. Now, let's talk about the interaction between Win2K3 DCs and RODCs. By show of hands, how many of you have deployed or are planning on deploying RODCs? That's a pretty good number. So one thing that you need to be aware is that we have this setting called auto-site coverage. And what happens is that Win2K3 DCs don't know about RODCs. The first RODC was born about 4 years after Win2K3 was launched. So if you have an RODC site that is not covered by any other writable DC, what Win2K3 will believe is that that site is not covered by anyone, and it will take a step further and it will say, I will cover that site. So if you have auto-site coverage, which is the default case in Win2K3, and we have a client that is requesting a writable domain controller, or not writable, but is requesting any domain controller, the DC that will be returned is the one in the other site. So you need to be aware that if you have interoperability between Win2K3 and RODCs, you might want to disable auto-site coverage on the Win2K3 DCs. In this case, the RODC will be returned. Now let's move into a concept that we introduced in Win2K8, and that is the concept of next closest site. And how can I play with the RODC filtering that is introduced in Win2K8 as well. So try next closest site basically is a flag that will tell DC locator to modify slightly a little bit the algorithm of discovery. So the typical algorithm is, please give me a DC in my site that meets this specific criteria. And if there's no DC in that site, then DC locator will fall back to what we call global records. So basically any domain controller in any part of the domain, in any site, that will be considered to meet this specific request. So with try next closest site is imagine that you have a site, two regional sites, one in America, one in Europe, and you have a small branch office in Europe. And that small branch office only has one RODC, and a client is requesting a writable domain controller. In this case, if try next closest site is not set, then any of the domain controllers in the other regional sites can be returned by DC locator, which is it's an undesired situation because you don't want clients, for example, logging on or authenticating against or using applications using DCs in a far site. You will have timeouts, you will have a bad experience to the users that are logging on, for example. So then with try next closest site, you will be able to narrow your DCs considered to a specific site. And that site is the closest based on the site link costs that you define as an admin. So that possibly is nothing new about knowledge, but one thing that you need to be aware of is that we have this next closest site filter setting. And what that is depending on the deployment of RODCs in different sites, those sites can or cannot be considered as next closest sites. So in this case, if the client is requesting a domain controller, in this case a writable domain controller, what will happen is that the sites that have RODCs on it won't be considered as next closest sites. So in this case, even though the top and the bottom sites have a lower cost than the left one, those sites are ignored. Now you can play with that and you can say, I will set it to a specific value to consider sites that have RODCs but at least have one writable DC. So in the case that you have a site that you consider insecure, for example, and it's only RODC covered, then you might want to ignore that one. But if you don't want to ignore any RODC, you say, you know, any RODC is exactly the same as a read-write DC in terms of security and capabilities, then I will just disable the next closest site filter. And you need to disable it because by default, all RODC sites will be ignored. So before I jump to the next topic, let me summarize what we have seen so far. So we understand, and now we understand how DC locator works. We have seen the limitation of the 55 domain controllers that it has. We have seen the auto-site coverage and the implications when you are deploying Win2K3 DCs and RODCs in the same domain. And we have seen how next closest site filter will allow you to consider or to ignore sites with RODCs. Now, let me jump to the next topic in my list of topics, and that is Windows Time Service. So there is a concept that we call time discipline, and Windows Time Service is the one that will be able that will perform this process. Now, why time service, or why time in this particular case? Time is critical to all the different AD processes. So similarly to DC locator, that every critical process would use DC locator. In this case, every AD critical process will depend on accurate time in the domain. So you can think about different problems that you can have because the time is not synchronized in the domain. That could vary from authentication issues to even getting lingering objects that are the cause of many problems in AD. So the way it works is that there's a specific algorithm in time service that is called domain hierarchy that will make sure and will guarantee that every two components in a domain will have a specific delta in the time. And you can think and you can imagine what different requirements we have on authentication, for example, with Kerberos having a delta of maximum 5 minutes, for example. Now, accuracy, and this is a question that I have received over the years, and the typical request is, I want to have accuracies of milliseconds, for example. I want to say that that is not the goal of time service. The goal of time service is to make sure that critical AD processes work fine on the deltas in time that are in the domain. Now, similarly to DC locator, it's configurable both group policy and registry. Now, let me tell you how DC locator works and what is this concept about discipline. So there are two clocks. One is the hardware-based clock. That's the one that you see when you boot the machine up and you go to the BIOS. So that's the one that it is always ticking, even if the machine is off. And there's one soft clock that is managed by the kernel of the OS that will get a sample from the hardware-based clock and will allow time service to discipline it. So we have the hardware-based clock ticking, and then we have the soft clock getting a sample from the hardware-based clock. And this is the case in which you have turned on your machine, or you have the machine is waking up from hibernation, for example. So when time service comes up, the first thing that it will do is try to find a domain controller that is a time server. Now, what component do you think time service will use to find that domain controller? DC locator. That's a great answer, yes. Now, when it finds one, it will request a timestamp. And the DC will return the time that it's on its system. And if time service sees that there's a delta, then it will discipline and it will ask to a slowdown in this case, for example. Such that on time, the time between the domain controller and this specific time client will converge. And the reason why we do that is, first of all, we want to avoid any time jump. So imagine the case that you are reading your event logs, and then you see 12:01, this event happened, then 12:02, this second event happened, and then you see 11:59. So you want to avoid that, right? We wouldn't be able to trust any events, for example, or any diagnosis. So that's why, instead of we changing the different time back and forth, we discipline the clock, and we make sure that by changing the frequency of the ticking of the soft clock, we arrive and get to the same time in the domain. So there is a concept of not only, okay, there's a delta, well, that's when discipline happens, but also if the difference is large, which is defined by a specific setting that you can control by group policy or by registry, then to avoid worse problems in the system, we actually set the time of the client to that specific time sample. If the difference is too large, which is also defined by another setting that you can tweak, then we simply ignore that sample. And the reason why we want to ignore it is we want to avoid all those big jams. To tell you a story, while we were self-hosting Win2K8 in one of our internal domains, we found out that a domain controller that had a specific hardware issue had suddenly a time of something like January 1st of 1967 or so. So there was like a jump of 50 years, and of course that created a bunch of issues in the system. But this, now moving on, time service also, there are also considerations when you are deploying RODCs in your deployments. So let me tell you how time service or how time synchronization authenticates. So we have a time client and a time server, and the way a time client will request a timestamp to the time server is by giving their identity. In this case, the client will tell, okay, this is my read, please give me a timestamp. The domain controller, who has all the information about the different machines in the domain, will look up the NT4 hash password of that specific account. Of course, the domain controller will have stored all those hashes, and it will use that to, along with the timestamp that domain controller has, hash and create a digest with of the timestamp and send it to the client. So the client that knows its password as well, and rather I would have said probably LSA instead of SAM, so the local security, the local LSA, then the client will be able to decrypt this digest and get the timestamp. So that is the way you can know that you are getting a timestamp from a valid domain controller, and there's no rogue time server that is returning invalid timestamps. So why is this important when you are deploying RODCs? Well, RODCs don't store passwords by default. And if RODCs don't store passwords by default, then there's no way that the RODC will be able to get the NT4 hash password of the account and then return the digest to the client. What will happen at this point is that the RODC will chain that request to a writable domain controller. So you want to make sure that you open UDP 123, which is the NTP protocol port, if you are behind a firewall, for example, if you are in a DMZ or in a secure branch office. Now, if the RODC has cached the password of the account, then the RODC will be just a regular domain controller in that case. By show of hands, how many of you attended yesterday's virtualization session on virtual DC cloning and virtual DC in general? Okay, that's about half of the room. So we have received this feedback from customers asking about what's the right thing to do if I'm deploying virtual DCs. And the principle that you want to apply at this moment is, well, you need to let time service do its thing. Basically, whatever time service was designed to do, you need to let it do it. So for those of you who have followed a specific guidance that we released in Win2K8, I want to say that please dismiss it. And the way I'm saying this is because what we have published at that moment would not be specific to the best practice that we want to convey. The documentation changes are on the way, but basically at that point we said, okay, let's disable the integration services for host time synchronization completely. But the problem with that is that those integration services will be required when time service is not running, and that means when you are resuming a VM, for example, when you are booting up a VM, at those moments, you will need to have that synchronization from the host. But then, what's the right guidance? And the right guidance is to disable the VMIC time provider, which is under a specific registry key that you can see in the slide, and by setting enabled value to 0. And what it will do is that it won't act as an additional provider to time service, and time service will act freely as it should. So, I want to touch on a specific issue, or rather concerns from some customers that after Win2K8 came to us and raised this particular issue that I'm going to talk about. Back in 2008, in the interest of reducing the footprint of services in Windows, we changed some of the behaviors that we had by default in Win2K3. And that included the start type for some of the services, and some of those services included time service as well. So if you are wondering what the behavior is for different versions of, if it is a workstation, for example, or a domain join machine, or if it is a DC, you might see some differences if you are trying to compare one by one. And the behavior, for example, in workstations, we added a specific task in Task Scheduler that would run every 9 days and would start time service. And we added the logic in time service such that when it synchronizes from the time source, it will shut down immediately. So next time, the next 9 days, then that Task Scheduler task will start time service again. On domain join machines and on domain controllers, the service, it is always running. But there's a caveat and there's a specific consideration that you need to have in mind, and is the start type can vary if you are going to sample different DCs. But it's not totally random. Basically, time service will be in demand start, basically in manual mode, for domain join machines and most domain controllers, except one, and that is the first domain controller in the domain. What will happen is that on domain join machines and replica domain controllers, there will be a domain join trigger that will start the service when it's needed, not when other services are running, and that way we can make the whole startup process more efficient. Now, the first domain controller in the domain is set to auto start. Typically, that's the DC that you set to sync time from an external time source, for example. So you want to have that as automatic. Before I move to the next topic, we have seen how time service works in general. What's the difference between the hardware-based clock and the soft clock? We have seen how the different what's the authentication process when you are getting a time sample from the time source. We've seen what considerations we need to have in mind when we are deploying our raw DCs, and we've seen what are those implications on virtual DCs. And the last takeaway is that we've seen that the service type will vary from machine to machine. We have a question right here. The question of the gentleman is, if we retire the first domain controller in the domain, should we make sure that it is set to auto start? As a best practice, yes, you might want to have. In general, if you are, typically the PDC is the one who is synchronizing from an external time source. So if you have a reliable time service that instead will synchronize from the external time source, probably you might want to have that DC as auto start, in general terms. Now let's switch gears to deployment, and specifically about upgrading Active Directory. So let's say that we have two different sites in two different domains, and we are going to introduce the first up-level domain controller in the domain. So the first thing that you need to do is you need to prepare the schema. And for that matter, you will need to run the forest prep process from the adprep.exe binary that comes in the media, not the adprep.exe binary that probably is in system 32 in the Win2K3 machine that you are going, for example, to upgrade. But you need to be aware that you need to take the bits from the media in the right platform. If you are deploying a Win2K8R2, for example, you need to have the 64-bit version of AD-Prep. Or if you are deploying a Win2K8, you want to make sure that you have the right version of it as well. You will need to have enterprise plus schema admin privileges. Enterprise admin privileges are not enough. You need to have permissions to update the schema. If you have played with these different ACLs on the enterprise and schema admins group, you might get problems with the update. A question here. Yeah, the question is, can we run the AD-Prep, Forest Prep, or the schema preparation from any machine? The answer is no. You need to run it on the schema master. There's no, that's a limitation that we have up to Win2K8R2. So probably the information that you got up to Win2K8R2 is not valid. Oh, I see. The comment here was that it was a specific schema update on a specific application, and certainly you can target specific schema updates for applications from different machines. Thing about a schema update is just a set of LDAP queries and writes to a directory. So in this particular case, you would be able to do that. Now, the AD-Prep.exe Forest Prep that runs some ACLs and specific schema preparation, you need to run it in the schema master. That's a must. Now, the second step that you need to follow is run domain prep. And the requirements for this process is that you need to run domain prep on the domain infrastructure master of the domain that you want to prepare to introduce that domain controller. But one thing that you need to have in mind is that before you run domain prep, that infrastructure master needs to have all the changes that the schema master had when you run forest prep. So you want to force a replication process between those two domain controllers before you run domain prep. Now, you run AD-Prep.exe domain prep, again from the media, and you will need domain admin credentials to run this operation. There are two optional processes that you can run. One that is required for RODC introduction in the domain. And what this process will do, which is called RODC prep, it will prepare the application partitions. Think about, for example, forest DNS zones or domain DNS zones to be able to replicate out to RODCs. So you need to make sure that if you are deploying RODCs, you run RODC prep. You can run it from any machine in the domain, and you will need enterprise admin credentials as well. Why enterprise admin credentials? Well, it's because that process will contact all the infrastructure masters in the domain, in the forest rather, and all the infrastructure masters hosting application partitions. And the other optional process is GP prep, and you will need that if you are upgrading from Win2K3, and it runs along with domain prep. You will need domain admin credentials, and also you will need to have GPO update credentials. And I'm mentioning this because also in one of the domains that we were self-hosting recently, we noticed that we never run GP prep from Win2K3. So what we noticed is that along that time, since probably 5 years ago, as part of the admin processes, we made a separation on the GPO admin privileges and the Active Directory domain privileges. So when we were running GPprep for the first time, we noticed that the GPprep failed. What did we do? Well, we needed to add back those privileges, run GPprep, and then go back to the previous scheme. Now, once you have prepared the forest, the schema, the domain where the domain controller will be, and the optional RODC and GP preparation operations, you will be able to introduce that first domain controller, either by upgrading one of the existing down-level DCs or by running DC promo on the new machine. For that, you will need domain admin credentials. Now, let me summarize what we saw on the last topic. Basically, we learned what considerations we need to have when we are upgrading to the new version of Windows, specifically the new version of Active Directory. We learned where to run the specific processes, what privileges we needed to have in mind, and we learned that adprep.exe that we need to run is from the media of the target OS and is not the one on the down level. Now let me switch gears now to, okay, we have a question here. The question is, what does GPprep does? Well, GPprep prepares, sets some ACLs in GPOs, in specific GPOs, such that you can have resultant set of policy enabled. So that means that if you have different policies applied to specific accounts, you can see the resultant policy applied to that account. Good question. Now, let me move on to touch on some specific troubleshooting miscellanea. And who are familiar with Directory Services Restore Mode? That's what I expected, yes, almost all the room. Now, imagine the scenario in which you run DC promo, you know, the previous example, and you go through the wizard, and the very last page before you commit, there's a specific input that you need to enter, and that is the Directory Services Restore Mode password. So at that moment, you say, oh, I need to enter a password, let's try this, and then you enter that password, and you're happy. You have your new Win2K 8R2 deployed in your domain. Then 6 months later, something happened, and you need to perform a disaster recovery operation, which, as you may know, you will need to access Directory Services Restore Mode. So you go and boot the machine, you press F8 and select Directory Services Restore Mode, and then a password is requested. And then you think about, what is this password about? And now you think, well, 6 months ago I set a password, but now I have no clue what I put as a password. So there's a trick, and there's hope. You don't need to reinstall your DC. There is a specific option in ntdsutil.exe that will allow you to synchronize once the password from one of your domain accounts to the Directory Services Restore Mode password. So you can go, in this scenario, run ntdsutil, and you can say, I want to synchronize the DSRM password of this DC to the password of my admin account. So that has proven pretty useful in these cases. Yes, please. Sure, but you can, well, okay, the question is, shouldn't you need to log on to the specific domain controller that of course, you need to run a disaster recovery process? Wouldn't that defeat the purpose of doing this? Well, you can run this from any other DC, and you can connect to that specific machine, and you can say, I want to synchronize the DSRM password of this particular DC with this account. The question is, if the machine is down, how can you sync the password? And the answer for that is that you will be able, well, probably, I don't know if Brian is around here. I can follow up on that answer, but the truth of, the way I think it works is that the DSRM password will be able to, whenever you log on to the DSRM mode, you will be able to contact the directory to get that password out. So after the session, we can get into more. You cannot. So the comment was that the gentleman having an experience with this. If the DC is corrupt, you won't be able to do that. So what this means is that you will need to proactively set it to the domain controller in the local LSA. The password. The question is does that password stored in directory or in the local LSA? And I will follow up after the session. We can follow up on this same point. Now, about one typical problem as well is that we were taught that if you are using local system or network system and you are authenticating with the current credentials, you will be able to go out to the network using the machine account identity. And if you are using local service, then you will go to the network as anonymous. And that is true except for a specific case, which is if you are using NTLM and you are using local system, then it will go to the network as anonymous. And why is this important? Well, typical problems that I have seen using LDAP is that if your application is running as a machine account and you are accessing the directory, it is very typical that you will get a bind issue, for example, if you don't have a specific SPNs in the directory for that specific account, machine account, such that Kerberos can work. So Kerberos will require 3-part SPNs. So if you have SPNs that are 2-part, for example, Kerberos will fall back to NTLM. So let's talk about ETW tracing, and we can see one example that will touch on the point that I have just mentioned. So the way you can enable tracing on Win2K8 and Win2K8R2 is by running NetSH tool. You can do that as well by running tracelog.exe or maybe other tools as well, or by setting specific settings in the registry. To see what are the providers that support tracing, you can run NetSH trace show providers. And you will be able to find out that for the Active Directory components, you will have a wide variety of providers across the different components. So let's take an example. A specific user reports that he or she is not able to connect to its ADSI application. So the first thing that you would do is, okay, give me the ADSI traces. And then you set up ADSI traces, and you examine them, and you see that they're generate connection failures on ADSI. Then you know that ADSI is built on top of LDAP, so then you set up LDAP traces, and then you examine them, and you will see that you are binding as anonymous. And then you remember that that you are always connecting to the machine account if you are running Kerberos under Kerberos and not NTLM. So you decide to set up Kerberos and NTLM traces, and with that you will find that NTLM is used because of the lack of three-part SPNs in the directory. Similarly, if, for example, in a different case, you can see that ADSI is reporting DC locator issues. So you can go and set up DC locator traces that will allow you to tell you that, okay, I cannot reach any live DCs. And as in the example that we did at the beginning, you see and you check all the DCs are live and running. So then you go and set up DNS client traces, and you find out that there's just a misconfiguration on the DNS gateway, for example. So that's an example on how you can combine the different traces among different components to get to the point and the root cause of an issue. Now, let's talk about Windows File Time. And probably you have been familiar with those big numbers that you get when you see the last logon timestamp, for example. So to use, in this example, let's say that we are using PowerShell, and we are getting a user, and we are getting and fetching the last logon property to see when this particular user has last logon. Now, you will get all the information, and then you will see a big number that is not, it's not very useful at all. But then you remember that there's a tool called Win32tm.exe that you can use to translate that value. So if you do that to the NTTE function, you will be able to translate that value. Now, the function in Win32tm.exe, it was a progression of a tool that we have, or a command that we have in nltest.exe, that is the time command. And I will let you know that this is all that you need to know. This is where if you have all these long numbers, you will use NTT function in Win32time. But just for the sake of completeness, let me tell you how it was. And I will just go very quick on that. On PowerShell, you can translate a decimal number into hex very easily. You can use something like this. So when you have this hexadecimal number, you will be able to take the high and low sections of the number and then pass that to nltest/time, and you will get the same exact translation. Now, you will be just better off running with 32tm/NTT. Now, let me summarize a little bit what we discussed on the tracing and troubleshooting. Well, we've seen how you can sync the password from a domain account to the DSRM password of a specific domain controller. We've seen how you can set up traces among different components and how you can get to a root cause by combining them. And we've seen how you can translate specifically last logon decimal values to meaningful values. We have a question in the back. Can we turn on the mics on the halls, please?
Hello? Okay. Just a quick note on the last slide where you showed PowerShell the logon timestamp, or the last logon. There's also last logon timestamp that's replicated. The last logon, that's an integer 8. You can use the PowerShell command get-date to actually do that conversion natively within PowerShell, and then do the convert. So it works great. That's
a great point. You can use the get-date commandlet to also do that translation. If you are not using Win2K8R2, or you are not using any PowerShell tool, then on down level you would need to use Win32tm/NTT. Thank you. Now, switching gears to replication, while I was preparing this section, I noticed that we have a lot of information about replication in TechNet. And for those of you who were in Dean's presentation yesterday, he covered a good chunk of tips and information around replication. But the one point that I want to touch here is about AD connection ownership. Now, again, if you go back to the appendix, you will see probably around 50 slides on replication alone, how it works, what a naming context is, how replication works, what's the, the high watermark table, what's an USN, things like that being touched on yesterday. But in this particular one, I want to mention that, KCC, the component that calculates the topology for replication purposes, will be able to manage those specific connections based on the number of DCs that are in the domain, for example. But typically, you will see something like that. You will see an automatically managed entry in the UI. And if you, for any reason, have changed a specific value or anything on the connection object, you will see the GUID of the connection object. And that's the way you can very easily spot that connection object is not managed by KCC. So why this could happen? Well, probably by you trying to do something like setting up the site link cost for a specific connection. You accidentally went to the connection instead of going to the site link cost in sites and services. And actually, we had an example yesterday. A lady came to me and she was asking me why if I'm changing something in the connection object, I will get this message in the UI saying that probably it won't be managed by KCC. And the reason is that the connection object will inherit all those settings from the site links and the site link costs that you have, setting sites and services. So that's where you will need to change them, such that the connection can inherit those. So you don't want to have specific connections non-managed by KCC. That could lead to different issues unless you have something like specific segments that you want to replicate specifically onto a specific domain controllers. So what happens if you see something like that? Well, if you go to the connection object and you will see the options attribute, you will see that something like a number 12. So what does that mean exactly? Well, 12 will be the result of adding 8 plus 4. But if you see the bit number 0, the decimal value 1, which means that it's owned by KCC and will tell KCC to manage this specific connection, is not set. So if you add 1 to that specific value, then you will see that connection will be now managed by KCC. What you need to do, basically make it an odd number, and you will be able to convert that ugly GUID into automatically managed again. A question here. That's right, exactly. Now, if you have changed the site link cost in the connection object, make sure now that you do it in the site link. Otherwise, KCC will try to override all those values. Now, let's move very quick on the last topic, and that is the protocol head surface. So you would say, what the heck is that? And basically, the aggregation of all the communication requirements of all the different components that Active Directory comprises, and all those communication requirements will add into what we call the protocol head surface. If we put that nicely into a table, it would look something like that. For specific scenarios, like in the case of a domain join member to a domain controller, those are the different ports and protocols and interfaces that you would use. Why is this important? If you are behind a firewall, if you are segmenting networks, you might want to allow or deny specific traffic based on the traffic that you want, or on the scenarios that you want to enable. Some of the considerations, well, LDAP can work on SSL, or you may want to allow GC LDAP access, for example, so those are different ports as well. If you are enabling Active Directory Administrative Center, then you might want to open 9389. And if you want to allow password change, you will need to open TCP 464 as well. Similarly, if you want to talk about DC to DC communication, for example, you are deploying an RODC in a specific segment, and you want that RODC talking to a specific DC, you might want to have specific rules in the firewall that would allow this traffic or that would prevent a specific traffic. The example of the time service and time synchronization, in the case of UDP 123, if you want the RODC chaining, for example, time requests from clients in the RODC side to a writable DC in the hub. If you are using DFSR instead of FRS, then you will need to open 5722 as well. So let's talk about the case of a DMZ or a segmented network. The best practice and the recommendation here is that the replication that happens between the writable domain controllers in the hub and the RODC is controlled in some way. And the way that you can do that is by setting up replication to one static RPC port. And the way you do that is by setting up some specific settings for AD replication or for file replication or for DFSR if you are using it. So that way, that specific RODC will get all the replication changes from one specific domain controller through one RPC port. So, so at this point, I want to open for questions. So please use the microphones on the halls, so for the sake of the recording. So we have a question there. Can we, yes, please, again.
I was under the impression, actually, in our work environment, in our corporate environment, when we attempted to deploy an NTP server, we ran into the issue of we wanted to use a Cisco appliance as an NTP server, and it didn't work. And I ran into an article that stated that Windows uses SNTP as opposed to NTP. Can you shed some light on that?
Okay, SNTP on the time synchronization? Yeah, well, SNTP is basically just an implementation of NTP. It's not a full implementation of the NTP RFC, but basically that's what SNTP would mean. We can follow up after the presentation on that specific sysvol problem. Yes?
My question is about sysvol replication and tracking it. In 2003, there was tools like Sonar and Ultrasound. Is there a replacement to those products with DFSR?
DFSR.
Because Sonar does not work, and nor does Ultrasound to track replication of sysvol.
Yeah, I don't know the answer to that question. Probably we can follow up after the session with Ryan or with somebody else. Can you say that? The comment on the gentleman here is that DFSR has some health built-in tools in Windows. Well, you can find me tomorrow in the exhibition hall. And after the presentation, you can come and ask any questions. Please don't forget to see the other sessions that I have suggested in the related content. And also, don't forget to provide your feedback. That is very well received. Thank you very much.